Explain why, in spite of nearly the same electronegativity, nitrogen forms hydrogen bonds while chlorine does not. Now, this is a very interesting proposition, a very interesting claim. Do you actually know, first of all, how was hydrogen bonding guessed? Why do people say that something like a hydrogen bond exists? I'll give you a very beautiful data. If you just plot the boiling points of HF, HCl, HBr and HI, this is the order of boiling points versus molar mass. You find that HF has abnormally high boiling point. HCl is minimum. That means HCl does not show any special characteristics as such. The abnormality is only attributed to HF, and we say this happens because HF has hydrogen bonding. HCl, HBr and HI, since they do not possess hydrogen bonding, increasing molar mass causes an increasing boiling points, but since HF has extra attraction because of hydrogen bonding, HF has the highest of these boiling points. My answer is, had chlorine also shown an abnormal rise here, we could have said that HCl also undergoes hydrogen bonding. But the fact remains that HCl does not show any such deviation experimentally, so we can safely say that no hydrogen bonding exists in HCl. This is the experimental proof. But this is not what they're asking. What they're asking is the theoretical portion. Why should nitrogen form H bond? I have not included nitrogen here, but if you see a similar graph, nitrogen will show you NH3. This is the boiling point. Then you have PH3. Then you have ASH3. And then you have SBH3. The nitrogen is very funny in the sense that nitrogen shows you a boiling point which is in between ASH3 and SBH3, but still all it means is that nitrogen in ammonia has some abnormally high boiling point as compared to these. PH3, ASH3, SBH3, because of increasing molar mass, they show higher boiling point, but nitrogen has abnormality because of hydrogen bonding. So nitrogen shows this deviation because of hydrogen bonding, chlorine does not show. This is an experimental proof that yes, HCl contains no H bonds while ammonia does. Reason? Same. We agree that ammonia is a polar molecule. Yes. And hydrogens are delta plus here. Fine. In HCl also you have a polarity. Fine. This has delta plus, this has delta minus. And honestly, in case of HCl, you would find that chlorine and nitrogen, if they have similar electronegativities, delta plus also would be significant on hydrogen. But the size of Cl is bigger. And that is why when they try to form hydrogen bonding with another HCl molecule, the distance becomes larger. Because of bigger size of Cl atoms, because of larger distances, you find that a good hydrogen bonding is no longer possible. How can I show it with surety? Because of this data. I have an experimental data that it does not show. That means that size has become so large for Cl as compared to nitrogen that while nitrogen was able to show a bit of hydrogen bonding, not much here. Please note, it is not highest, it is in between. But HCl shows nothing because the huger size actually just cancelled out the benefits of high electronegativity, and no hydrogen bonding is possibly seen in case of HCl because of bigger size of Cl as compared to nitrogen atom.